Hello, ICID students. How are you today? I'm going to go ahead and talk to you about our solving one-step equations by using the additive inverse quiz. And so I hope that you did this quiz and that um, the teacher was able to correct your quiz. And I thought maybe we can go over a few of these. So let's do a few. For number 1, it's pretty standard. X plus 7 equals 12. So of course, I want to get x alone, so I need to get rid of this plus 7. So the opposite of plus 7 is minus 7. Whatever I do to one side, I do to the other. So I bring the x down. This zeroes out, and I show that by drawing a line through this, equals, and then 12 minus 7 is 5. And then, of course, I'm going to circle my answer, right? Circle my answer. For 2, I have y minus 8 equals 13, and on the left side of the equal sign, I have the letter, the variable. There's my variable, so I need to get rid of minus 8. So what's the opposite of minus 8? Well, plus 8. Whatever I do to one side, I do to the other to keep the balance. Draw my summation line, and then I bring down the y. Minus 8 plus 8, that becomes 0. So I'll just draw a line through it. And then here I'm going to bring down the equals and exactly right below in the same area. And then I'm going to add 13 plus 8. And so 8, 9, 10, 11, that's 21. And then I'm going to circle my answer. For here, I can see that my letter is over here, my variable. So I need to get rid of this part here, right? I need to get rid of that. So this is positive 4 because there's not a minus in front of it. So the opposite of plus 4 is minus 4. So whatever I do to one side, I do to the other. Draw your summation line. Bring the a down. 4 minus 4, of course, becomes 0. So I'm going to draw a line through it. Put the equal sign right below that equal sign. And 5 minus 4 is 1. And circle my answer. I'm hoping that these are pretty self-explanatory. They're all the same. Let's go ahead and look at a few that people tend to miss. I'm going to go ahead and do, let's see, I'm going to make this a little bigger so I have a little bit more space. And we're going to do number 8. Of course, y is here, so I need to get rid of this to get y alone. So how do I get rid of minus 6? Well, I use the inverse. I use the opposite. And what's the opposite of minus 6? Well, plus 6. And whatever I do to one side, I do to the other. And so this, of course, zeroes out. I'm left with y equals, and 2 plus 6 is 8. Let's look at 9. I'm going to rewrite it right here. I'm going to rewrite it. N minus 6/10. Oh, yes, that's a decimal point. Equals. Let's go back to the quiz. I know you're wanting me to do those challenge problems. And don't worry, it's things that you've done before, right? These things you have done before. Fraction people challenge. Woot, woot. Now you have a calculator with an ABC fraction key. So feel free to use that if you missed our fraction lesson. Right? Oh, fabulous. What's going on with my internet? Oh, there we go. So for 11, I've got r plus 1/3 equals 2/3. Now this is the same thing, right? Where's my letter? Oh, it's right here. It's r. I need to get rid of this stuff that's on the same side as my letter r, right? So what's the opposite of plus 1/3? Well, it's minus 1/3, of course. So I'm going to say minus 1/3. And whatever I do to one side, I got to do to the other, right? Here's my summation line. I bring down the R. And here, I know 1/3 minus 1/3. Well, of course, that'll be a big fat 0. So I zero it out just like I would with everything else. Bring down the equal sign. And then, of course, I'm so lucky I have a common denominator, right? My denominators are the same. So then I just have to pay attention to the numerators. And what is 2 minus 1? Well, it's 1. And it's 333, right? And I'm done. Same thing. Now, number 12 came out kind of funny, so I'm going to rewrite it right here. Let me just get a different color. I've got 7/12 equals D minus 5/12. The number that's on the same side of the equal sign that's over there next to my D, so I need to get rid of that. So what's the opposite of minus 5/12? Well, it's going to be plus 5/12, right? Because that's the opposite. We're going to solve by using the inverse, the additive inverse. And whatever I do to one side, I have to do exactly the same thing to the other side of the equal sign. And of course, this is zeros out. Then I'm just left with D equals. And I'm so lucky that my denominators are the same. They're both 12. So I just have to deal with the numerators. And I'm adding 7 plus 5 is what? 12, and my denominator is 12. Oh, do you guys see that? It's improper. The numerator and the denominator are the same, so I know that whenever I have the same number over itself, it equals 1. So really, D equals 1. But you can also put the top number in the house because it's improper. And double check and know that there's a 0 remainder, so my answer is 1. But of course, any number over itself will equal 1 because it's the shaded over the total. I shaded the whole thing. Now with number 13, I'm going to go ahead and give myself some space. So this is 13. M plus 2/9 equals 2/3. So the first thing I'm going to do is get rid of this 2/9, right? Because I need to get M alone on the left side of the equal sign. So what's the opposite of plus 2/9? Well, minus 2/9. And whatever I do to one side, I got to do to the other. And then this M I just bring down. Of course, this is going to zero out, so I forget about it, and I put the equal sign. Now I have to deal with this mess. Oh, look, my denominators are not the same. I cannot add or subtract until they are the same. They have to be in the same family, be the same parts of whatever number they come out to be. So I look for the largest denominator. And what's the largest denominator? 9, right? And then I ask myself, can the other denominator evenly divide into it? Yes, it can. 3 can go into 9. Great. So now I found my lowest common denominator. So I'll say 9. 9. Oh, that's a 9. And then 9. Going to go ahead and raise to higher terms, right? 3 times what number is 9? Oh, well, 3 times 3. Whatever I do to the bottom, I have to do exactly the same thing to the top. 2 times 3 is 6. Now here, you'll notice that 9 times 1 is 9. So whatever I do to the bottom, I got to do to the numerator here. 2 times 1 is 2. Now remember, I'm subtracting, right? 6 minus 2, well, that's 4. And so that's my answer here. M equals 4. Nice. Let's check out these last couple. And here. So 14 I've got x minus 3/8 equals 1/4. First thing I got to do is get rid of this 3/8. So what's the opposite of minus 3/8? Well, plus 3/8. Whatever I do to one side, I do to the other. And then I have x, this will zero out, equals, and I notice that I've got different denominators. Gosh darn. So I look for the largest. Which is my largest? 4 or 8? 8 is. Does 4 evenly divide into 8? Why, yes, it does. So then I raise to higher terms. 8, 8, and then 8. And so I'm going to go ahead and raise to higher terms. 4 times 2 is 8. So whatever I do to the bottom, I do to the top. And here, 8 times 1 is 8. Whatever I do to the bottom, I do to the top. And 3 plus, or 2 plus 3 is 5. Then I've got 15. So I'm going to do it over here. 5, 6 equals y minus 3/4. Of course, here's my variable, so I need to get rid of this minus 3/4. So what's the opposite of 3/4? Well, plus 3/4, right? And whatever I do to one side, I got to do to the other. And there's my summation. I know this will zero out because it's minus 3/4 plus 3/4. That'll be 0. So I have y equals, and then I have to figure this out. Now this is best done perhaps over here. So maybe I'll take this right here and I'll do it over here. So I'm going to say 5, 6, and 3/4 because I need some space on the right hand side to raise to higher terms. The first thing I'm going to do is look for my largest denominator because I can see already that my denominators are not the same. And so my largest is 6, right? And so what does 4 evenly divide into 6? No. So then I have to say 6 times 2. What is 6 times 2? Oh, that's 12. 12 works for 6. 12 works for 4. 12 will be our lowest common denominator. And so I'm going to go ahead and raise to higher terms. 6 times 2 is 12. So whatever I do to the bottom, I got to do to the top. 5 times 2 is 10. Here, 4 times 3 is 12. Whatever I do to the bottom, I got to do to the top. And so 3 times 3 is 9. Then I'm going to go ahead and add it. And this is improper, right? Normally we'd have to simplify. But in this case, in algebra, we keep fractions in the improper form. So I'm going to keep it here. It's okay if you said this equals 1 and what is this? 7/12. That's okay too. But you'll see why when we start graphing that they really just want to keep it like this a lot of the time for algebra. Not necessarily for the high set, but for algebra, we do keep it in improper form when we're graphing. Okay, so I hope this helps, and I'll see you in the next video.